Okay, so this chapter, it's on a brand new concept. You did not do this in Math 9 at all. The concept is called factoring. So I just want you to write factoring here. What's going to happen is I'm going to be teaching you 4 different methods of what's called factoring, and you'll learn that today. Today is the first out of 4 methods, and it's a method of factoring by GCF. You have to understand today's concept because Monday we do a brand new type of factoring, has nothing to do with GCF, but GCF would be the simplest of the 4 different types, okay? So just make sure you've got a good grasp of what we're doing today so that for the next lesson you will be okay. I want you to flip your page and I want you to just look at this. You don't have to write this down. I'll explain it to you. And if you do want it written down later on, you could just go to the video and pause it and have this. You know how to find GCF for numbers. And in chapter 1, we did GCF of numbers, and I gave you huge numbers. This unit or this chapter, you're going to have very small numbers. You're going to be able to look at a number and tell me the GCF. Okay, so you don't have to worry about doing that prime factorization that we did. What is going to be new, though, is finding out the GCF for a set of variables. So remember that variables are letters. What's going to happen is I'm going to give you different terms. So this would be 3 different terms. And I'm going to say, what is the GCF of these 3 terms? You have to do 2 things in order to get the GCF. First thing, you have to make sure that the variable is common. So there's an x, and x, right? So this x is common. Then the GCF of these 3 terms, it is going to be the variable with the smallest power. That's going to be the GCF. So in this example here, if I say what is the GCF, it's going to be x. You've got a 4, power of 3, power of 9. The GCF of this would be x to the 3. Later on, I'll show you why it's going to be the smallest power and what we're going to do with the GCF, but for now, we're just going to practice finding GCF. Write down 6a cubed and 9a squared b. So 6a cubed, 9a squared b. You're going to have to find the GCF of this. You always start with the numbers. And you say to yourself, between a 6 and a 9, what is the biggest number that you could divide out of both? 3. So that would be our number. Then you say, okay, a to the 3, a to the 2. A is common. So I get to pull out some a's. How many a's are you going to pull out? Are you going to pull out 3 or 2? Yes, always the lowest power. So you're going to say a squared. And what about b's? You're not going to pull out a b. It has to be common. So this is b to the 1. There'd be b to the 0 here. There's no point in pulling out a b to the 0, right? You just don't pull it out if it's not common. And that would be your GCF, would be that guy there. One thing I just want to show you, if you have a hard time, I'll show you a trick. If you have a hard time looking at the 2 numbers, so these 2 are easy, right? Most students can look at that and say 3. If you have a hard time figuring out what the GCF is, you take the smallest number, which is the 6, and you say to yourself, what are the factors of 6? What are all the numbers that divide into 6? So 1 and 6, 2 and 3. You then take those numbers and you say, what is the biggest number factor here that also is divisible by 9? And that would be 3, right? 9 is not divisible by 6, so the GCF is 3. Okay, let's go to class example 1. Write down 8x squared y2 and 20xy cubed. I've given you 2 different terms. GCF equals, write down what you think it is. Now, I know you guys don't need this, but I'm just going to do this off to the side. The factors of 8, so between 8 and 20, I'm going to take the smallest, which is 8, are 1 and 8, 2 and 4. So you would look at those numbers, and what's the biggest number here that divides into the 20? 4. How many x's? 1. I've got 2 x's and 1 x. The GCF would be x to the 1. Between y squared and y cubed, what do you want me to write? Y squared. That's the GCF. Okay, let's look at class example 2. Write down GCF equals 12 and 15. What are you guys saying? 3. Yep. So again, you could take that 12 and you could say 1 and 12, 2 and 6, 3 and 4, right? And then the biggest of these numbers that goes into 15 would be 3. How many A's, how many B's? 1A, 1B. That's the GCF. Do B for me. Don't worry about that negative. So tell me what you think the GCF for B is. Anais, what do you think for B? Akil, what do you think? That's right. 6 x to the 3 y squared. That would be the GCF. The biggest number I could pull out of 18 and 24 is going to be a 6. Yes. I'm going to talk about the negative in this example. What it's basically going to be is if you start with a negative, you're going to pull out a negative, is how we're going to do that. So because the negative was the second term here, you just disregard it in this question. C sometimes throws students until you have a couple examples, and it's the number, right? So they'll look at this and they'll say, what's the biggest number I can pull out between a 1 and a 2? What is it? It's a 1. Because remember, if you're doing that trick, the smallest number is the 1. If I said, what are the factors of 1? What's the only factor? 1, right? So that has to be the GCF. Basically, if you can remember, if any of your terms have a 1, that's going to be the GCF, no matter what the other terms are. So it's going to be 1. I'll write it here for now. And then it would be, do you agree that it would be AC2? Yep, that's what it would be. And then at the end of the day, I'm going to get rid of that. I didn't pick B, and the reason why I didn't write a B is because it's got to be common. There's no B in that term. So now try D. And I sort of told D to Carly for this one. If you start with a negative, so first find what pretend the negative's not there. So just say to yourself GCF, and you're going to say, okay, 10, 20, and 40. Hopefully everybody knows it would be 10. If it starts with a negative, just put a negative in front. That's how you're going to do that. And then you figure out your variables. And Raiden, what would you have for that? Negative 10. Yes. Negative 10 a squared b. That would be your GCF. I'm going to give you some practice before what was the point in doing this? Like, why are we doing this? So open up to your homework. Question number 1. I want you to circle question 1. It says use prime factorization. You're not going to do that. You're just going to write 12a cubed and 30a squared GCF is equal to, right? I don't, prime factorization. Yes. You could, or you could do the trick of take the 12 and 1 and 12, 2, this would probably be faster, 2 and 6, 3 and 4, right? And then just say which of those numbers, which is the biggest number that also goes into 30. The numbers will not be big though. Okay, they'll all be under 100. Most will be under 50. they're going to be like small numbers. For number 2, let's write them down. It wants you to find the GCF of 10xy to the 4 and 25x squared y 3. So write GCF. And then for number 3, circle number 3, all of those. And it actually does spill onto the next page, number 3. I'll just pick a couple on the next page so that you get some practice with negatives. You could do H, K. Actually, let's not do K. This is the biggest numbers you'd see, would be that guy there. So we'll do H, L, and I on this page. I'll give you 5 minutes to work on that. Okay, so we'll continue on page 323 and see how we're going to apply the GCF. If you have your highlighters, you could highlight factoring. And remember that this entire chapter is going to be on different methods of factoring. And the method that this lesson focuses on is factoring by GCF. So what you would see for all of these questions, essentially, they're all going to say the same thing, and it's just going to give you the word factor. And then it will give you something to factor. What do they want to factor? So I will give you an expression. So my expression is going to be 8x squared y squared plus 20, so I just want you to write this at the top, 20xy cubed. The first step in factoring is you need to find that GCF. So off to the side, you would write GCF equals. And then you'd say to yourself, what's the biggest number that you could divide out of the 8 and the 20? What would that be? It would be 4. X to the 1 and y squared. Okay, so you get that GCF. What we are going to then do with this GCF is under each term, you're going to draw a division bar, and you're going to write that GCF under each term in your expression. So 4x to the 1 y squared, 4x to the 1 y squared. What you then do is whatever your GCF was, whatever you divided each term by, you write it again, 4xy squared, and then you open up a bracket. What is going to go in the bracket is the answer to this division. So 8 divided by 4 is 2. Then you say x squared divided by x1, that's quotient law. 2 minus 1 would give you 1x. And y squared over y squared would cancel. Bring down the plus. 20 divided by 4 is 5. X over x will cancel. Y3 divided by y2, quotient law, subtract the exponents, you get y. That is your answer by factoring. You have completely factored that expression. So you would box this in, and that would be your answer. Now, watch what happens. This is what I would have given you on the quiz, right? And instead of the word factor on the quiz, I would have had the word expand, right? How would you expand this? How would you get rid of the brackets? Yeah, taking that 4xy squared and putting it back in. So one thing that some students like about this factoring unit is when you get your quiz and when you get your exam, many of you will have time. You would box this in because that's your answer, but then you could check your answer, right? So how you would check your answer is if I redistributed this back in, watch what would happen. 4 times 2 is 8. X1 and x1 would be x squared. Bring down that y squared. Plus 4 times 5 is 20. I would have xy cubed. Do you see that? This is what we started with. So if you factor, and then you want to know if your factors are correct, you simply take whatever the GCF was and redistribute it back in, If you get your original answer, you did it correctly. Okay? So there's some students who, mostly the APs, right? They'll get their answer, they'll have them all boxed in, and then before they hand in their test, if they have time, I could see off to the side, they've re-put them back in to make sure that they did it correctly. But we're not going to do that for these. We're just going to go through and factor everything. All right, let's look at class example 3. I want you to scratch out after the equals. We've got 3 terms. 5x to the 4, 5x to the 3, 5x squared. Above, write GCF equals. Nice and easy. GCF should be 5x what? X squared. A division bar goes under each term, and your GCF gets written under each term. 5x squared, 5x squared, 5x squared. That's really redundant, but if you do this, you'll do it correctly. Then you write that GCF always in front of a bracket. Your answer goes in the bracket. So you take each term and you say 5 divided by 5 is 1, or cancels. x4 divided by x2 is x squared, plus 15 divided by 5 is 3x to the 1, plus. This is interesting at this one. A lot of students are going to make this mistake on the test. Here's what they will do. They're going to go x squared over x squared cancels, which they're correct. They're going to cancel the 5s, and then they're just going to leave that blank. What do you have to put there? A 1. Yes, the x's cancel, but 5 divided by 5 is 1. I just didn't put the 1 here because I knew I had an x squared, right? But that would be your answer, and you would box that in. You could get rid of, if you want to, like, I don't need that invisible 1 there, and I actually don't need this guy. And then if you really wanted to, you could say, did I do this correctly? And you simply have to redistribute that back in, and you will get that original question. It will be identical. What you have is there's 2 what's called factors. So your GCF is always going to be one of the factors, and then the answer in the bracket, that's your second factor. So if I say what are the factors you would get once you factor this, you would say 5x squared is one of your factors, and then you'd say x squared plus 3x plus 1. That's your second factor. You're always going to have 2 factors for GCF. Okay, question 5. I will do A and B. Then we'll find the GCF for these 3, and you'll factor those 3. So it says factor, right? This word here. Oops. Factor. Okay. 20 and 6. What's the GCF? Look at the 6. What are all the numbers that go into 6? Yes, it's a 2. Whatever your GCF is, you put a division bar under each term, and you put that GCF underneath. The GCF then goes in front of a bracket, and the answer goes in the bracket. 20 divided by 2 is 10x. Bring down that minus. 6 divided by 2 is 3. You are done. You have factored. Next one, B. GCF equals. Danny, what do you think the GCF of that is? Yep. And then how many x's? Yes, 4x squared. 2 division bars, 4x squared, 4x squared. The GCF goes in front of your bracket. Answer goes in the bracket. Jaden, what are you writing for the answer? Yes, perfect. 4x squared is the GCF bracket, 4x squared plus 1. Because remember, x squared and x squared cancel, but 4 divided by 4 is 1. You have 2 factors. If I ever said just what are the 2 factors, 4x squared plus 1. Okay, I'm going to call different people to give me the GCFs, and then you will do the factoring. Because you'll get it wrong if you get the wrong GCF. So we got to just make sure that that's correct. If you're watching at home, pause the video, find the GCF. Okay, C. Yannick, what are you getting for the GCF of that guy? Yes. GCF for D. So find the GCF for that guy. Oliver, what are you getting? What's the GCF for this one for D? Okay, just find the GCFs for now. Like, don't factor. Find the GCF of this guy, find the GCF. Yes. 3P is correct. Somebody want to raise their hand and tell me E? Who's got E done for GCF? I'm just going to check. Julie, what would you get? Yes. GCF 5 x y squared z squared. Okay, now I'm going to pick three different people to give me. You don't have to give me the GCF. You just have to tell me what's in the bracket, so that factor there. Carly, do you have C done? What did you get for in the bracket? What's the factor? Yes, and that's the answer. 5a squared plus 4b plus b squared. You box it in, make sure the GCF is boxed in as well. Bitsu, do you have D done? Okay. Who's got D done? Danny, what's the answer? Yes. 4p squared minus 2p plus 5. Take a minute, finish E, and then I'll call somebody for E. Okay. Nathan, do you want to try B? Or sorry, E? How many Z's did you say? Is he correct? He is. Yep. The second factor was 5z minus 4xy squared plus 6x cubed z to the power of 3. Let's do one more class example, and I want you to star this one. This is a perfect quiz or exam question. Probably quiz. All right, what it gives you is it gives you a cone, and it gives you the formula for the area of a cone, the surface area of a cone. So if ever I give you a shape, you will always be given the formula for that shape. So they just say, if you were to paint this cone, that's the surface area, it's pi r squared plus pi rs. And then what it says for the first question is it says determine the surface area of the cone to the nearest 0.01. What they're telling you here is what they want you to round to, which is 2 decimal places. That's what this is telling you. And then they say it has a slant height of 7.4 So the slant height is 7.4, and it has a radius of 2.6. So the first question, it's going to be a calculator question. Can you plug this into your calculator? So area equals, always write the formula first, okay? So pi r squared plus pi rs. Area equals pi. Make sure you put radius in a bracket, and it was 2.6. The square goes on the outside of the bracket, plus pi r goes in a bracket, which would be 2.6, and s in another bracket, 7.4. You will enter this in one string on your calculator. So pi r squared would be 2.6 squared plus pi radius, I'm going to put in a bracket, 2.6. Close that bracket, open another bracket, 7.4. You don't need to put in the multiplication signs here. Your calculator will automatically do that for you. There's the area. They want it to the nearest hundredth, 2 decimal places, so it would be 81.68. So remember, area equals 81.68. What would be my units for area? Yes, and it even actually tells me here, centimeters squared. Okay, so we've answered that first question, right? Nice, easy question, junior high question. Number 2, write the formula for area in factored form. So I'm going to do mine up top. If you guys have room, you don't have room. So find somewhere else to write this. I want you to write down pi r squared plus pi r s. If I say factor this, you have to figure out what the GCF is. The pi throws students. So just pretend that that wasn't pi. Just pretend it was the number 3, right? If I said 3r squared plus 3rs, what would you pull out? A 3, right? So between a pi and a pi, if I've got a pi here and a pi here, I could factor out a pi. So pi, how many r's do you want me to take out? 1. How many s's do you want me to take out? None. That is your GCF. Draw your division bar. Put a pi r under each. Remember, that goes in front of the bracket. Your GCF goes in front of the bracket, and whatever you get after the division goes in the bracket. Pi divided by pi will cancel. R squared divided by r to the 1 is r, plus pi over pi will cancel. R over r will cancel. What am I left with? S. So the area in factored form, which would be what number 2 is area is equal to, the GCF goes first, and then the second factor is in the bracket, r plus s. That's the second question. So I'll give you a different shape, probably. Actually, in your homework, it gives you, I think, a cylinder. It has to give you the formula, and then you just GCF it and factor by GCF. Now, watch what happens in 3. It says calculate the surface area to the same, they want it to the hundredth, using the factored form. So now write this formula down. Okay, area equals pi. R was the radius, which was 2.6. R plus S, I could just do in a bracket 2.6 plus 7.4. Now you're going to enter this on your calculator, exactly as you wrote it. So second function pi, r was 2.6 and then open bracket 2.6 plus 7.4. What do you notice? It's the same. If you factor correctly, you have to have the exact same answer. Because remember, from my factored form, I could then just redistribute this back in and get the original equation. So you will always get the same. If I give you something, numbers to check, I say verify R is 2, S is 3. You will get the exact same answer. So area equals 81.68 centimeters squared. All right, let's do the rest of the homework. I'll tell you what to circle. This will just be factoring. We're done GCF. Now you're going to factor. Circle number 6. Circle number 7. Circle number 9. Number 9, do what it says because it's fairly basic. It says number 1 factor and then verify, expand to verify. So I do want you to do this, right? Because a lot of students in this class will be doing that on the exam. And then number 10. The only thing about number 10, so it's a different shape, right? It's a cylinder. Let's fill this in. It says the vertical height is 14.5 centimeters. So let's put that. 14.5 centimeters. And then it gives you not the radius. It says the base diameter is 11. What would the radius be? What do you do? Yeah. The radius, remember, is half of the diameter. So if I give you a diameter, you just take that number, divide it by 2, and then you have the radius. And then number 13 is a good question. And number 14. Those are both really good.